Welcome to the Cutting Edge Podcast. Today we have Dr. Anatoli Borissov, who also actually happens to be my father. And we're just going to talk a little bit about, his life, his career, what he's doing now. Lots of accomplishments, obviously, throughout his life and career. And so, welcome to our podcast.
Hello.
Basically, I'd like to start with a little bit maybe early life, right? You grew up in Siberia and kind of in Russia and Siberia, part of Russia. What would you say are some memorable early life experiences? For example, I know one, you told me that you finished two schools, the school that you were basically going through in your city, in your town, and also another school that you would send assignments to. Can you go through something maybe early life?
Yeah, it is interesting. I lived in a small town called Petrovsky Zavod. This town was established in 1780s and named after Peter Great. And so this town has like 30,000 people, but it has maybe 10 or 15 plants, different manufacturing plants. So it was like two metallurgical plants and remelting plants from whole Siberia, and they bring the old metal machines and military technique, so we can go easily to this plant and take this explosive powders, guns and everything, and we can play with this.
Oh wow. So you were actually able to go and as young juveniles or before you became adults and go and like mess around and actually go and
yes, we played.
Wow.
We have gunpowder. I have the whole bag of gunpowder, so I can exchange for bicycle, for whatever with my friends, and it was tough. And then maybe from this time I start interested about ballistics, about explosions and about combustions and everything. But principally I was enjoy to build something by my hand and try to understand how to build and why it's work. And so, and 7th grade I already built airplane, model of airplane, and I installed on this airplane the radio control system. So it was like first drone really in that time.
What year was this?
It was 1962.
Oh wow! So you were building drones in the early 60s.
Yes, built and controlled this, and then I started asking why it's flight, how it works. So I start studying aerodynamics and reading some good journal for young schoolboys and peoples, which calls technique for youngest people, and it was all schematic. It was explain everything. So, and also it was interesting that we have any store, so you can go and buy capacitors, you can buy resistance, diodes and everything, and you can solder it, your electronic schematic, and use this.
So it wasn't just a small kind of town. It was the town big enough with Zavod means plants, with lots of plants and lots of. But my grandparents, your parents grew up maybe more simple, right? Like they didn't end up achieving the heights and degrees that you achieved, right?
Yes,
what was your father and mother?
Yes, but my father has a very famous profession, the same as Jesus Christ. He was carpenter. Yes, my mother was working in the department store. So, but anyways, then I understand that I can build anything. I can build any airplane and control this. Then I start enjoying mathematics and physics and how to do this. And I put a lot of questions to my school teachers. They not always they can answer it for these questions, but.
Okay, so well, basically then you're going from high school to then I believe you have to in Russia you have to serve a couple of years, right, in the military when you're coming out of high school.
No. If you then I start doing mathematics. I took first place in Olympiad in in our state, in the Chitinsk region. It's big state. So, and I went to the all Russian Olympiad in Voronezh. It was big, very big achievements. And then I start studying at the school and the Moscow Physical Technical Institute, one in Dolgoprudny. This is the most famous physical institute. It was Landau was working over there, and so on and so on. So I graduated this as secondary high school, and I graduated my first high school. Then went to university, and
what university did you go to then?
I went to the University of Tomsk University. This is one of the oldest in Siberia university, and graduated Department of Mathematical Physics, and with specialization in ballistics, in internal ballistics. That means rocket engines and design and simulation, calculation. And
what do you think made you go like maybe specifically into physics and mathematics, and maybe not another field?
Yeah, because I told from the beginning, from the childhood, I was interested to build. It was interesting for me to build something to which flight and why it flight and so on and so on. So it was such.
But that's more engineering, no? Or
no, it's start like from engineering first step when you build, and that's it. But when you start asking how it's flight, this became already science. So you need to study physics more, mathematics more, deeper, and put a lot of more questions. Just not for engineering. Engineering, there are engineering and there is science. Engineering is just you have already knowledge, and mainly you have already procedure, and you have already like protocol, and you have already formulas which you can use and calculate and design something. For example, pipe, what pipe has pressure inside, and what there must be thickness of this wall of the pipe, and you just open the book, open the manual, and calculate this.
But to be able to do that, you have to. What you're saying is what you do before that. Science is physics. Is you do the analytical steps and the computational steps for an engineer to be able to then create or build something, right? Is that kind of what physics and mathematics, you're putting together kind of the background, and then they're going to build or design whatever it is?
Yes. There are different engineers like electronic engineers, electric engineers, and mechanical engineers. So they working in the area of mechanics, for example. So they study mechanics, and mostly they study the engineering, how to build, what formula to use, what the mechanism, how it works, But then there is another level at which you study this new phenomena and try to understand, and then try to implement into the practice, into the life, into the manufacturing. This is some kind of science, and then you got this knowledge and give up this knowledge to the engineers, and then they build and so on.
So from there, so you finished college, and then kind of where my sister and I came about was you moved to Novosibirsk and Akademgorodok, which stands for basically academic town. Can you talk more about
Yes, I graduated at university. They suggested me to stay at university, to go to PhD at university, but I told that no, I cannot live in the cradle all my life. So I went to Akademgorodok. It was new academician city. It is like big campus in which we had 25 basic institutes. Nuclear Physics Institute, Thermophysics, where I work, Institute Theoretical and Applied Mechanics, Institute Hydrodynamic, Cytology and Genetic Institute, all knowledge. And so this was in one street, and it was very high level of the scientists from when it was built in 1957, and all big scientists were invited to this institute and to this Akademgorodok, to corresponding institute, and they start working. So it was.
If you had to compare let's say, that
Mhm.
part of or that city in this academic town
Mhm.
with all these institutes to, let's say, another situation like that here in the United States or anywhere in the world?
Yeah, yeah.
Is there something similar for people to kind of gauge their mind?
Some kind similar, like the same as NASA, for example. But
Okay.
NASA has also many institutes in many cities. And for example, in Houston, we have this big campus where there are a lot of different institutes which devoted to different tasks.
Mhm.
But for example, here is it not for academic study, but this is for just implementation of all of this knowledge and to build, not to build Houston NASA Center. It's corresponding to the crew teams which go in flight. So, but this academician city, it's like all knowledge, not only space or mechanics or rocket engines, but all knowledge, as I told, cytology, history, sociology, genetics, and all of this. So it's covered all knowledge of the. So it was very different. It is one of the best places in Russia for creative work, because if you have any idea, you can go to neighbor institute, for example, Institute of Inorganic Chemistry, and discuss your idea, your
So you would work
development.
together sometimes on
Yes,
projects.
yes, sometimes together. Yes, yes.
What would you say? What would you say your first breakthrough
Mm.
was in your let's say in your career, a major breakthrough?
Yeah, so one of the major breakthrough, no, it was already I was working. I studied as a PhD student, then I graduated PhD and start working as scientific researcher, and then I studied the propagation of the. My PhD was devoted to the instability of combustion of the rocket engines, and did this work and defended dissertation, and then after that I continue and I started study the wave propagation, like pressure waves propagation, density wave propagation in different media, and then I did discovery together with my brother Alexander. He was 4 years younger than me, but he came to the same institute and he was also doing PhD. I was already chief of laboratory, and we put the problem to solve how the wave behavior at very high pressure and high temperature. It's called near thermodynamical critical point. Which is very important state of the substances near the at high pressure and high temperature. For example, it's many rocket propellants work at near this stage, and this stage it's of the matter. It's very interesting because it has abnormal properties. For example, speed of sound in this state goes to 0, and compressibility goes to infinity, and heat capacity goes to infinity, and so on and so on. So it's produced very big influence on the design of the work of the engine, so they can explode if you don't take this.
You're not careful. Huh?
Yes, if you don't take into account these properties and design properly. So
Can you explain a little bit about the top-off cycle?
It's maybe later a little bit.
Is that later
Let me
in your
finish
career?
with this. So we put experiment, and I did theory and experiment, and we prove that existence of the rarefaction shock wave near the thermodynamical critical point. And so it was discovery, and it was recognized as discovery in Russia, and I was invited to many countries, England, China, Japan, and everywhere in Europe. So I did presentation about this discovery, and so this is we discovered it experimentally and theoretically. And in that time we work. I work with very famous scientist, academician Yakov Borisovich Zeldovich, who also predicted such state, and he was also one of the co-author of our discovery, and he was 3 times hero of the labor in Russia. He designed the atomic bomb and the hydrogen bomb for Russia in 1950s. So, but then he started working with in cosmology and so on and so on. So it was very good experience to work with such people. And then
so let's a little bit fast forward. So basically, you're doing your work, your research, study, development, and I think you got all the way up to almost like the director of the whole institute there. We leave at this point. We immigrate here to the United States in the early 90s. And you got a Fulbright grant, I know that, and taught at University of Maryland.
Yes.
Then you came to Houston.
Department of Aerospace and like spring semester, and then they invited me to University of Houston, Department of Mechanical Engineering, where I work 2.5 years. And at the university we did also very interesting and breakthrough work on the swirling, turbulent flow. And we got analytical solution for this. Analytical solution, it's differed very much from the CFD. You can get some kind of CFD solution, but CFD, it takes a lot of times, and you cannot repeat this for many different parameters. But analytical solution give you a formula, and you can calculate phenomena of swirling flow, for example, in the confined volume in combustion chamber. By very quickly, analytically, and you can change parameters and investigate and build much better design and much better chamber, which more better performance. So this is.
And then okay, so going forward, I know at that point meet your good friend till this day. Even shout out to Mr. Jim McCoy, and you start working doing some business with him. And U.S. Navy, and kind of explain that early 2000s, late 90s part of what you were
doing. After university, they invited me, University of Houston, they invited me to one company, and this company had problem with diesel injectors, so I did a mathematical model and solved this problem and improve the injections of the diesel fuel inside of the big marine engines, and we reduce NOx very much and increase efficiency for the diesel engine, which was very surprising because diesel engine already have very high efficiency, but using this invention and using this analytical solution and design and invention and building testing, we improve even better diesel engine. Then and I got several patents, and then I went to another company, and for the gas industry in the United States, we have like 10,000 engines which drive compressor on the compressor station, which push the gas from Texas like to through whole America. And but this engine were very old, and they have very bad emissions, especially NOx. And so I start working on this problem again, using my knowledge, analytical and mathematical and physical in combustion. I invented new supersonic injector for gaseous fuel for natural gas, and we reduce NOx on 99%. When we did first testing in Oklahoma on the gas compression station with this gas engine, we did experiment. We measured NOx, and NOx was 99. Like instead of 20 gram per brake horsepower, we have 1 gram. So nobody believed. So we use, they invited 4 different companies, they measured it, but it was such...
yeah, I heard someone say, so I forget who it was, but they said even if you can show like a 3 to 5% increase in performance in something, whether it's a product or service, you should start a new business. So 99% is crazy. I mean, that's such a big improvement.
Yes, it's crazy, nobody believed. But they invited 4 different companies which measured all these emissions, and they come to the same numbers which we measured from the beginning. It was breakthrough. Why? It was because I used my knowledge and my analytical skills and physical skills, skills in physics, not to improve to 1% or 5% like many companies were doing in that time and doing still now. But I did not like this. I always used to shoot for the 100%, or even starting from this discovery of rarefaction shock wave, because even now you can open the book for university, like gas dynamic book, compressible flow, and you can read that there is no possibility to existence of the rarefaction shock waves. But we told that no, it can be, and we prove. And by the way, some of the books already include that we did such discovery. For example, Courant and Friedrich's books about supersonic
Do they mention
flows.
your name?
Yes, they mentioned my name and our work. And so they mentioned that these books which claim that it cannot exist, it's wrong. Now we have knowledge. And the same with any others, like with this supersonic injection gas fields. And then I built, I organized my own company, General Vortex Energy, where we work and for Navy mainly, and we did a lot of work for Navy. And finally, for example, I did combustion chamber, which was working, and you have expel of the combustion gases at temperature 1500 Kelvin, very hot. But you can hold this chamber in your hands while
Yeah,
it's
I
working.
remember that picture in your office
Yes,
where
there
you
is-
have that.
Yes, so this is breakthrough, and I did this, and we did again. It start from the analytics. It start from the fundamental knowledge, not from CFD. I use CFD as well to confirm some complicated geometry, whatever. But it's impossible just using only CFD to make any discoveries.
Yeah, that's
So-
truly, I think, probably one of the greatest accomplishments you can have in your career is if you're literally rewriting history books or books that people study. And I think that's kind of mostly a pattern of your career, right? In
Right,
physics and
right,
mathematics,
right.
even to fast forward to our company in drilling, in drill bits. And in between fluid bits, you had some time where you worked at Firefly Aerospace. And how was your experience there?
I worked for Firefly Aerospace 6 years, and for 6 years I got 7 patents. And also, my boss, Tom Markusik, he is Doctor of Science and also a very smart guy, rocket scientist, and he told me, Anatoly, could we build the top-off cycle of rocket engine? I told, yes, Tom, let's do. And I did calculation, everything design, and we always arguing with him, discussing,
Mm-hmm.
And finally we design. I calculate all the flow field inside of the combustion chamber and everything combustion, and then we build this and we test it and it works. And the main people try to, in rocket scientists, it's very, very advanced science rocket, and they try to build such kind of the top-off cycle in 1960s. Very big company, Aerojet and Boeing and everything, but they cannot. They did not accomplish this, and why? Because they didn't know a lot of field formulas and maybe knowledge like I do. So anyway, so we built this and we tested, and this mainly combustion chamber top-off cycle. When you have in the rocket engine, you must have some kind of the gas generator. This small rocket engine, which drive turbo pumps, which provide fuel, propellant, oxygen, and kerosene, for example, into combustion chamber. So this small engine, it just works as pump. So what we accomplish? We throw out this gas generator, and we use the combustion chamber from which we took this gas, cut gas from one part of the chamber and put into the pump and rotate this and this pump. So we exclude a lot of things like combustion, ignition for the small gas generator, all plumbing and everything. So, and you can imagine first stage, they used to in first stage like 4 engines, 3 engines, no, 4, 5, and Elon Musk use 9, in Falcon 9, and also use 33 engines, and all of them, they have all this gas generator. And I was able to get rid from all this gas generator and just use these combustion gases from main chamber and put this combustion chamber gases from main chamber into turbine, turbine wheel, which was rotating by these hot gases, and this pump was now pumping the propellant into the main combustion chamber. So from scientific point of view, and from it was interesting that this combustion chamber now, which we use, and we have six flight on the orbit, very successful. And this combustion chamber, we have two zones. In one zone, we have low temperature, which need for the driving the turbine wheel, that it will not burn out. But then in another part of the chamber, we have high temperature, which we need to create thrust and so on and so on. So this is also some kind of the miracle, because like in one part of the room, you can imagine that you have low temperature, and another you have high temperature, and it's stable situation. It's working, and it's
not mixing.
Not mixing, yes, not mixing.
Well, it sounds like maybe we have to get you in front of Elon. Maybe you can help them out a bit. Only a couple-hour drive away.
Yes.
What do you think? So, what do you think is the next big leap in rocket engine design? Would you say, in your opinion, if you had to maybe go 5-10 years from now, what do you think is kind of the next step?
No, the next step is so we got this for this type of cycle patent, three patents or 4 patents, I don't even remember. We built rocket, Alpha rocket, and we had 6 flight. Recent flight was recently. We had another flight, so and it works. And so this is new. And it's a very good question, because now a lot of startup companies, they organize company, invited graduates, students, and they just came from, and they have computers, they have pretty good tools, and they can, principally they can design, they can build, but they cannot invent it something. No, first of all, maybe later they can invent, but now they're young, but now they can just build. Even students at University of Texas at Austin, they have a TRL laboratory in which they build while they study. But everybody can do this. Many startups. So you have the same product, mainly, not very much advanced. And so you have big competition, and many of these companies will die. So
well, I guess because people are, right, I guess this is a theme that we see in oil and gas and drilling, is people are just comfortable with kind of knowing that, hey, this is the thing that works, and we know it works, so if we just build it over and over, then with no real ingenuity or innovation, because they're scared to take a risk, right? To invent something, you have to risk, you have to think outside of the box, right?
Yes. So this is like the same, because and so in rocket science and rocket engineering, in the next like in 10 years, the company will survive like a company which has innovative design, innovation. So because everybody can build based on the knowledge which already exists, but you will not win competition. All competition will be one with new approaches, with new innovation, with simplification. Like I told, this type of cycle we use now in our rocket, it's allow us to get rid, like from, we have on the first stage 4 engines, and we get rid from the 4 gas generators. It's we reduce weight, so we can increase payload. We reduce complexity, we don't have ignition system for all this small gas generator and so on and so on. So one of the main that it will company will survive and will produce,
that has innovation.
It has innovation.
So how would you
have innovation? You have to have like Mendeleev, the father of periodical system. He told that to do this innovation, to do something new, you have to study at university, then you have to teach, then you have to work, and then you can do something.
Yeah, those experiences you have to go through. How would you? So we've talked quite a bit about your some early life, a lot about career, the move to the U.S. and 90s, 2000s work there, Firefly through the 2010s, and but now as we move to our company, Cool Edge Bits, which we started a couple of years ago, also we have something that was invented by you that's innovative, that's not like anything that's out there, which is kind of the hydraulics that we apply to our PDC bits that help with heat rejection and cooling. And so how would you say thermal physics plays a role in, let's say, drilling technology, ours or any others, just your knowledge and how you're able to create and invent something like this through all the processes, the analytical, the computational, and then the design and build? And
yeah, first you have to find some kind of the paradox, some kind of the so I found this paradox. I look for example, for the conventional drill bit, how they work, what they're doing, and the drill bit you make apply a lot of work to share, to drill, really, to remove the material, and by using cutters and using this device which has some kind of the blades, so it's rotate, it goes down into the well, so it's rotate, and these cutters, we have cutters, they remove the materials of the earth and
rocks,
all the rocks, yes, rocks. And so rocks is very, and this structure or lithology of this well can be very different. You can meet very, very hard materials, granite and so on, and quartz and chert and so on. So these cutters doing very, very big work, and while they doing work, they heat it up very much. And of course, even they made from the diamond, artificial diamond or natural diamond, they still have very high temperature and reduce their strength and wearing, and it's drill bit stop working. So in the conventional technology, they use this mud for lubrication, for the cooling, but this mud or liquid goes through this pipe and then goes through the nozzles, through the orifice, and goes between blades, and have to cool down these cutters. But it's cool down, but it's not enough, because the velocity immediately go down, and very small, and where you have small velocity, you have small heat transfer, and so on and so on, and you have back wearing. So I use my knowledge in thermophysics. I'm professor in thermophysics, and so I put like the best cooling methods using jets, which immediately direct the fluid and which cool down these cutters, and reduce temperature twice mainly. So
less heat down hole,
yes.
better, faster, comes out cleaner,
yes,
more
yes.
environmentally more responsible.
Yes, yes, and also because it's work at a cooler temperature, it does not wearing so much like conventional drill bit.
So more bit runs.
Yes. So when we drill and we pull out our drill bit, it was like new one. And in that time, nobody in the big different companies, they did not show the drill bit after drilling, like 7 feet. We show before, new one, and after when we pull out. And you cannot differ what was before, what was after, because when we pull out, it was like new. It was some small chips, but it was like new. So, and also we did experiment when we drilled 7,000 feet in Oklahoma through the chert, and they before our drill bit, they use 4 drill bit from Schlumberger, Halliburton,
all the
NAV,
big companies,
all the great big companies. They use 4 drill bit to drill for 7,000 feet. We use 1 hour drill bit, 1 pass to 7,000 feet and pull back, and it was like new. So
how would you say?
Also, it was the same surprise like I had before in gas industry with NOx reduction for big large bore gas engine. The same as top off cycle. The same with
Yeah,
So you
just
see, so this is like
mirror of your life and your
Yes,
work. Is
yes.
everyone says you can't do it,
yes,
it can't
yes.
be done, and
yes.
then when you figure it out, when you develop it, and then you show them that it can, they're like, oh, of course, it's easy, of course.
Right. When we did discoveries, when we start doing this rarefaction shock waves near the thermodynamical critical point, when we start study this and do this work, they told, oh, you will never get these critical points. We got it. Then they told, yes, you're right. I told you that when we did this, they told, oh, it's so simple.
Mm-hmm.
And now, like we do a lot of presentation with this drill bit, they told, yeah, but why you did this? How you did this?
Yeah.
Why this big company did not do this? No, because
that's
maybe
truly, yeah, no, that's a conundrum that comes up when we speak with investors, with customers, with engineers, is like, how did we miss this? How did we? And I say it's because a lot of times, a great invention is not some big boss telling a group of 10 people, go in that room, lock yourselves, and invent something great. It's usually, someone that comes that has a vast knowledge in physics, science, math, whatever it is, that comes maybe from another field, like you, rocket science and drilling engineering, and necessarily doesn't have a gun to their head or some type of big salary that some risk, of doing something wrong or getting fired, and it's simply just a hobby at first for you to see something, you see the flaw in it, and you say, I can actually probably make this better, and then go after it. So one thing I noticed too with you is, I would ask the question, how do you balance, because you're a very creative thinker, you think outside the box, you have many different ideas that we've learned and we've known and are learning that have become great inventions that are patented, that are produced, but how do you balance that creative thinking with some of the disciplines that have to come with engineering and mathematics and physics, because those are very disciplined sciences? How do you not let yourself get outside the lines with the creative thinking?
Yeah, but this creative thinking is getting out or arise from my knowledge, from my specialty in physics and mathematics, because I do. It's not all this idea did not come like when you in the morning when you wake up. Oh, I have good idea, I have invention. That's it, But no, it's yes. I see some paradox. I see some that it does not work, and it is interesting how to work. Then I think in not in just general words. I think in formulas, mathematics, applying and calculating. Okay, I'm going to this way. I'm going to use this mechanism, for example, jet cooling, how it will work. So I calculate how jet goes, how it spread, how it cool down, for how much, what the parameter, because it's mostly in physics you have a lot of parameters. For example, even for this simple example, you have flow rate through the nozzles, you have velocity through the nozzles, you have pressure, and so many, you have distance on which you have to hit the cutter, and so many parameters. So you try to generalize these parameters and come to some conclusions. Then you have to test and confirm for yourself. Like I'm the biggest critics of my ideas, my approaches, and so I try to prove that I am right, that I am not wrong, that by using my formulas, my calculation, my simulation, CFD, and analytics and testing, then I prove this, and then it's everything. If everything okay, it start phenomena, it start existing, and so on. So it's like it was many when at GVE we worked with Navy. And we built and built first combustion chamber, and they told that okay, we need third party testing. I told why? Oh, they will test. I told I am testing. I design and I am testing, and I try to testing on the extreme. When for example, when it's burn out, then I know, or when it's exploded, then I know. I have to and nobody, no any third part testing will make qualified testing to prove that it works or not works. Because you pay them money, they do some tests, several experiment, and that's it. But I am doing set of experiment,
Checking yourself.
checking yourself, but checking myself in more wider range of parameters, you know.
I think now, you know, and I don't think I know as well as we are, there's lots of companies and businesses that are starting to implement AI into their processes. I would ask you the question, how do you see AI impacting the future of drilling and energy systems, would you say?
No, it's any range, but what I would say, we use in rocket science and engineering, we use not AI, but we use NI. NI, I call it natural intellect. So, for example, in mathematics, it's there is methods which allow you to choose the best design. For example, you have to design the rocket engine which has high thrust but short engine, not very long, not very high weight, and so you design like to highest thrust but with lowest nozzle, for example, length, because if you have long nozzle, you may have very high thrust, but you have long nozzles, you have high weight because a lot of metal, so you have to optimize. And this is some kind of the problem. It's called variation problem of mathematical physics, and you put this problem, and all these tasks depend on many parameters: weight of the metal, density of the metal, length of the metal, thrust, combustion temperature, and so on. And so you try to find optimal solution in range of these parameters. And so this is natural intellect, and there are
do you see
mathematical physics.
Do you see a path for let's say realistic path for merging AI with mechanical systems like drill bits or engines?
We can say they already mentioned and not mentioned, but it's AI. It's a tool. It's another tool for me, for example, for engineer, for scientists, and no, for anybody principally. It's another tool. So you just use this tool, but it's not solution. It's not the solution for everything, you know.
Right.
Because
and it puts
AI
people out of jobs too.
Yes, and a lot of energy. For example, AI using chat GPT and all these guys, they mainly, what they doing? They mainly seeking and researching all the based of
available data, right?
Data and knowledge. Yes, data and knowledge. For this, you have to, yes, when you have very, very high capacity computers, fast computers, powerful computers, yes, you can absorb or you can search all the database from all the world. Yes, and you can find something which already done or which close to your task, to your problem, but you will not find the discovery. You will not find that
create or innovate. Right?
Yes, create or innovate, that you have to do like this. Now, after we have this for drill bit, we have patent. Now come into this worldwide database, and now they can find maybe, but still it's not my last invention. I have even more development for drill bit, for especially I have now working on the development of the rotating detonation engine, which I have a book in 1991. I had a worldwide conference on detonation, and now they doing some kind of detonation engine, but I still have this knowledge. I have now better decision, a better solution for new rotating detonation engine. So some company, Air Force, NASA, they start doing the testing, but using again my knowledge and my experience, and I have better solution.
And guess what you need? I'll grab this thing. Guess what you need for all this AI and all this data and all this. Actually, NVIDIA is building a huge, they just made an announcement, center here in Houston, as well as Apple. But what you need for that is a lot of power, a lot of energy, and that's how we get that with this thing, right? By drilling and in production and extracting oil, gas, water,
You mean
and producing the energy that's needed for all these AI
right.
centers. And so what keeps you after such a long life and such a long career with so many accomplishments, what keeps you motivated to continue to strive and come up with new things?
Main curiosity, I think. Main curiosity, and to try to explain the mechanism of any phenomena. For example, also I am working on the evolution of a model for the dynamic evolution of galaxy, for example, how it's produced, why it's such big sizes, and how it goes to the black hole, and so on and so on. So it's also a lot of mechanics, a lot of mathematics can be used, and a lot of my previous solution for different flows can be applied, and I see some.
Even our latest patent, you're working. We feel that you've kind of mastered not fully, but somewhat mastered cooling the outside of the drill bit, right? The cutting edge, the cutters, which is most important. But I spoke to some of our friends that are doing offshore and geothermal drilling, but I mentioned to them that you are now working on cooling the inside of the drill bit, which can help heavily in geothermal, the hotter kind of formations.
Yes, I'm working. And we sent a patent on this. We use not only the cooling of the cutters, which is also a very, very big problem, but also for such application, geothermal wells, and also super deep wells, offshore wells. They are deeper, so the surrounding temperature higher around this, and so not only cutters, that whole drill bits bodies start heating up, and it's not good. We found solution. We start cooling from the inside, and sent a patent. And
what would you say throughout your life and career, could be personal, could be career, what's the most valuable lesson, if you had to pick one, or maybe one or two, that you've learned from failure? Not success, but failure.
No, principally, I don't remember any failure. I never failed. Maybe I failed not to solve the problem in the time frame. But this time frame was installed by me, also not anybody. But so only this. So,
okay. So how do you feel? How do you feel or hope that your work will help future students and scientists and great inventors? And what do you hope to leave on this planet that you can then watch from high above of your children, your students, and younger people are accomplishing?
I don't know. I want to live that these people and anybody have some drive for the knowledge, have curiosity, have drive for the knowledge, and it does not matter if you come from any level of the society. It does not matter. It's just your own drive, and you can do a lot of using this.
Yeah, I think mentality, curiosity, attitude is really important, right? Because I mean, obviously experience and degrees and knowledge and all that, but I think if anything, if you just have a really good positive attitude and mentality about, hey, I'm going to learn this, and no one's going to stop me, and I'm going to get this done no matter what. And if I can't do this, I'll find that person to help me to get this job. If you have a great mentality like that, I think you can do anything, right?
Yes, and now, for example, it's much easier to learn, to study, and to print. Then it was like 40 years ago or 50 years ago when we went to university and we went to library. We have to open and find some books, some papers, and paper. It was mainly. Now you go on your telephone, you can find
ChatGPT.
Yes, ChatGPT, even And principally, I agree with. I told even before Elon Musk that I told that now you don't need to go to university. If you don't have drive to go to university, don't go, because you can learn, you can study immediately on website, on whatever. So for 1 week, the same as you do at university for 1 year. And
you can pretty much
don't-
teach yourself with all the
yes,
knowledge.
yes,
that's-
you don't, and it's much more efficiently because, like like when you go for the lectures at the university, you have whole semester, and you like having a good life. But when you need to do something, you need to study very intensively, and it's possible. It's free. You don't need to spend money. You don't need to spend time.
Get yourself in a hole and
Yes.
owe all this student loans.
Yes, and
all-
Elon Musk told the same. He told that now students don't need to go to university, and they just spend 2 years or 4 years in good company.
That's your university.
Yes. So yes.
I thought it was interesting. You told me because obviously we.
And just a second. And principally, some guys, even I would forbid for some guys to go to university because some guys have so good and so
It'll slow them down.
yes, directed mind and good mind that when they go to university, not only slow their mind, but they may break your mind,
Harm
they,
them,
they
yeah.
harm them. They put in different paths.
Yeah, roadblocks.
Yes, yes, some kind of the slow.
So, just to go back to, I think we were having this conversation, I don't know, maybe 5-6 months back, and we were talking to maybe a drilling engineer, maybe even a PhD. But I thought it was interesting that you mentioned that obviously we know that rocket science is one of the toughest sciences in the world, right? To be a rocket, there's literally, a joke about that, like, oh yeah, what do you think, I'm a rocket scientist? But truly, one of the toughest sciences, one of the toughest problems to solve, right, is how do we get up there and how do we go further? But you actually mentioned that your experience in drill bits and drill bit design and drilling and all the parameters that you talked about, that this is also, that you have much respect for the people in this space. Now this is also a very, very tough
Yes,
science.
yes. Of course, I was very surprised when I started doing this drill bit many years ago, and principally it has not so low profile challenging problem. So this oil and gas industry, they have most maybe rocket science especially was very burst in 1960s, 70s, 50s, and they did a lot of, and they still continue. But in the modern time, like in 2000 and 1980s, oil and gas industry, they come to more challenging problem than rocket science came. And they solved a lot of these problems. So
there's lots of innovation.
Lots
now,
of innovation.
In 2025, actually, there's lots of, I would say, lots of innovation in both. It's kind of a race now. What would you, which one would you say, forget about the last 60 years, let's say the last 5 years, which one do you think is more innovative or has more, because obviously oil and gas, I mean, the energy, that's how, I mean, it's one of the biggest industries on the planet, but it's also an industry that no other industry would survive without it, right? If we didn't have power or energy. But which one would you say has had more innovation in the last, let's say, 5 years?
No, I think in the last 5 years maybe the same, and not so many innovation in both sides, because they just use this innovation in rocket science. They use all this development in 1960s, 50s, 70s, and in oil and gas industry they mainly use all this innovation and achievements in like 1980s, 1990s. So it was over there. It was very big development burst in different direction and different ways, and so many. Now maybe little bit slower, but still I think it's I don't know, I don't follow now maybe very well for the whole oil and gas industry. I follow very close to the drill bits. Yes, so in drill bits I can tell that they stopped. I did not see any innovation except of our innovation. So they also work on different materials, but
cutters have improved.
yes, but it's not. not so much like it was many years ago. So
Well, that's why, our podcast is called The Cutting Edge. Our company's called Cool Edge because, we feel that we're coming to the space with something new, with something that no one else has. And
yes.
we're currently not just talking and having patents released. We're running drill bits and getting that data that's so, highly touted that speaks, people talk, but numbers scream, right? So what would you say if you had to go back to, let's say, Anatoli as a 16-year-old, and you're allowed to go travel back in time from now to you as a 16-year-old, and with all the things that you've learned in your life, what would you tell that young person, you as when you're 16?
When I was 16, I already was on the first grade at university.
Right.
First year at university, not waiting 18 years old like here is in
Yes.
in
But what advice would you
yes,
give,
so
let's say?
advice, I think 16 years old, it's already late to give some kind of advice on the career.
Let's say
and
10,
career.
11.
Yeah, 10,
younger.
11. Yes, 10, 11 and younger guys, Roman. So just try to help these kids to develop curiosity and to develop to do something by their hands, even very simple things, but let them do something.
Do something with your hands.
With the hands, because when we joke that the labor make from the monkey, make the people from the monkey. When monkey start do some labor, catching and using stick and so on, they became developing.
Turned into humans.
No, developing their brain. And brain was developing and so on. And so more you do labor from the young ages, more you develop your brain. So try to do this, and also this one, and another. Try to find from the, no principle in any age, but better if you find from your kids or friends some inclination in some area and their talent.
Right.
For example, you can find that kids have talent in 3-4 years. You can already indicate maybe they have good ear
music
to for music. Maybe they have good physical, for running or jumping or whatever, doing.
Yeah, in our
sports.
family with our kids, I've got 5 of them, Anatoli's grandchildren, and he's got 6. My sister's got 1. We always try to do, education is not a question. You better be getting good grades, but we always try to do music, art, and sports. I think those things, and then of course, you get the educational development in schools and hopefully outside with some tutoring. But
yeah, but the most, of course, it's parents. You spend, teachers do the very good job, teacher at school, but they can see only part of the day, 4 hours and 3 hours. But mainly it's parents, and they have to help, they have to find, they have to help to develop the talent of their kids, starting from the early age, and help them, not force them, but help them, and do this systematically, like you start something, you see and do this systematically, not just do in 1 year and then forget about this. So,
what would you say? So let's end it with this one, and I don't like to get political or too religious, but I would ask you, what would you say if you had a sit down, let's say, with our leader, with our president, Trump, and what would be, maybe from your knowledge and expertise, what would be maybe some advice that you would give, and y'all are similar in age, actually, I think, for the betterment of our country, for the United States to continue to get back into, really being that top superpower. I don't think we ever left, but to get back to how it should be, what is any advice that you would give the leaders of our country for just going forward, whether it's politics, science, anything?
Yeah, so this is, I was surprised when we came from Russia. I was surprised that when you go to school and your sister, I was surprised that school education system spent so much money, for example, per pupil, in comparison with Russia. But education in Russia was much better in mathematics, physics, chemistry, and all this science than here. Also here we have a lot of computers, a lot of the things, but it was incomparable. So all you go to any American university, in that time you can meet Russian professor of mathematics, physics, and from our city, from Akademgorodok, as well as from whole Russia. So, I'm glad that already President Donald Trump, he already start looking for education. He start working on this
right
education
away. Yeah,
right away, because
that's where it
he's
starts,
very well,
right?
yes.
With no, I think the last two things you said are great, because it starts with the young kids and teaching them and educating them from the home, from the parents. But it also, I mean, they're in school quite a bit. They're in school 6, 7, 8 hours sometimes a day. So it's like we have to pay our teachers more, and we have to focus on what we're teaching them and make that competitive.
Yes, and all this, and a lot of money in the United States went to the education. I think we spent
top.
But in education we are in place
not
20
top 40,
or
no,
40
it's
or
like 40 or something.
yeah, something like 40. So this is paradox, and it must not be like this. We must make this education system more efficient, and it's clear how to make. You know, in Russia they spend 100 of this money, maybe 1,000. And no, I don't know. I left Russia 31 years ago, so don't know how come. But in that time, but in China, for example, they also spend much less money. But all, for example, mathematical Olympiad, World Olympiad mathematics championships, Olympiad, and they show American team. It was all Chinese guys, you know, so
all Asian
because
guys,
the Asian, because they smart, they work hard, you know, and they achieve.
No, I think we have the resources here to do it.
Yes, resources.
And I like what you said too, is give more access to young minds, to students, to people like yourself, experienced professors who have breakthroughs.
Yes, and keep these people, help them. For example, if you find some talent, help them to develop from school to university, from university to institute to industry, whatever, to help them, you know, because you know that this guy already in young age, they show something.
My grandfather was very good at that. Alexander Leontiev, my mom's dad, I remember, always had young students, young people around him.
I prepared 6 PhD students while I was professor at the university, and I'm professional scientist. I work for Institute of Thermophysics, Russian Academy of Science, and I became professor. I became doctor of science, but I prepared 6 PhD students, and one of them, he defended PhD like 25 years old, and then he went. I sent him to defend doctor thesis.
Doctor,
which is like 6 PhD when he was 33 years old, because he was talented guy.
What's he doing now? Do you still connect?
He's still working over there. Yeah. So, but he was talented, and I helped him. I tried to help, and he wrote book, very good book, and so on and so on. So.
So okay, man.
Yes,
good answer.
And also about manufacturing, you know, process, you know, about manufacturing, all many plants and everything was moved to abroad, and now they try to come back to make policies that we can do over here. But for this, we also need to have some kind of the young people which going to work to this manufacturing. So at school, for example, we had in my time, we had some professional study to do. For example, I graduated school and I have carpenter license, so I can do something.
Like you said, do something with your hands from early age.
From early age. But when you graduated high school, I had carpenter, so I can go and work as carpenter.
I think it's going to take some time though, because even now we have like 500,000 manufacturing jobs open right now, ready to go, ready to work. and the administration is trying to bring another millions and millions more. But who's going to do them, right?
Yeah,
We have to have people
yes.
that are actually going to, we
Yes.
kind of know the state of the society that are actually going to want to go and get a shovel and dig, right? Or whatever.
Shovel,
So-
weld, and so on and so on. So, and we need to prepare it because maybe not all guys graduated high school and go to university. Maybe some want to go to work as
right
welder,
away to work, yeah.
to work as carpenter, to work as mechanics, and it's good. And they work maybe 2 or 3 years. They work further. If don't like, they can change or may go to university and
Yeah,
study.
you can always go back.
Yeah. So this is more.
Well,
I
I appreciate your time. I think we even went a little over an hour, but it's very interesting. Great conversation about obviously your life, your career, so much amazing innovation and continuing to grow and evolve, and even at a later part of your career, invent new things. And a great hour, and we had a good time, and we hope to have you back. Thank you.
Thank you. Thank you.